we're doing hypothesis tests, and there's no way around this. These things kind of take a while to get your head around. You got to figure out, you know, the steps involved, and there's lots of little details that sometimes come up and sometimes they don't bother to talk about them. They just like pass them by. So here's one of those little issues that they don't always go into. You shouldn't really use a hypothesis test except when certain conditions have been met, right? So it's only doable in some situations. You must use a sample. You can't do a census. There's no point in doing a hypothesis test. If you, for instance, suppose your question is, I wonder if the majority of people who work in my company like working in my company. And you asked everybody, but you get, there's no point in me trying to do a test. Is it more than 50% or anything? Don't I know everything I need? So it would be pointless, right? Although there is a question in the homework that does exactly that. Now, the second one you haven't talked about at all, the sample, right, has to be big enough. You can't just say, well, I'm going to ask 2 people and get any kind of evidence, right? Just not feasible. And so we have a test that's pretty standardized. I don't think I've seen any alternate version to this. It's sometimes called the 10 rule. And what it says is that n times p hat should be bigger than or equal to 10, and n, the sample size, times 1 minus p hat, right, the sample proportion, should be greater than 10. In English, that basically means at least 10 people have to say yes, and at least 10 people have to say no to whatever that question is, right? So if the question is, are you going to vote Conservative, yes or no, right? At least 10 people must say yes, and at least 10 people must say no. If you get fewer than that, you shouldn't be doing a hypothesis test. It's very risky. It's not likely to give you good results. Again, this one here is just taken for granted, but let's formalize it. You know that your sample should be a good sample, right? It should be nice and random. It should be a fair representation of the population, right? So it's not a good idea if you're talking about politics, for instance, that you only go to the poorest neighborhood and only ask people who live there, or you go to the richest neighborhood and only ask people who live there, right? You know, that's not a fair representation of everyone, right? So we typically assume that they did this, right? Even if they don't mention it. And very often they typically assume that this is true, although they don't always mention it. There are a couple of questions that they do, but quite a lot they don't. And we definitely assume that this is true, except for the one question where they ask you about it. So let's suppose then that we have a sample that is ready to go for a hypothesis test. Here are kind of some steps from the beginning to the end that you would typically do. Step 1, are the conditions met? In other words, should you be doing a hypothesis test right away? Right, can you imagine somebody says, oh, we got a sample of 8 people and 5 of them were in favor and 3 of them were against. Let's do a hypothesis test. You should say, no, not big enough, right? 5 people isn't enough yeses, right? And 3 people is not enough no's. Then you have to set up your hypothesis test, and it's going to have 2 pieces to it. The guy at the top is called the null hypothesis. We talked about that yesterday. That's what the answer used to be, or people believe is true right now, right? So the percentage of people who are overweight in France was 22%, right? That kind of question, right? And then you have an alternate, and there's 3 flavors of it. Do you want to prove that it's bigger than it used to be? Do you want to try and prove that it's less than what it used to be? Or you want to prove that it's, that it's not the same as it used to be, right? Here are your 3 choices. And it depends on the story. You know, there's going to be a story where George went to France and he saw a lot of fat people and he says, I think it's more than 23%. I'm going to go and see if I can prove it, right? So that's where you would say, I want to prove it's bigger than P0, right? P naught, anybody remember the fancy name for P naught? It was given a value, a name. Almost gave the answer there. P naught is called the null value, right? The null value. So, is it bigger than the null, less than the null, or not equal to? The vast majority of questions, you're going to use salt to get a guy called the p-value. The p-value is essentially the probability that you got the sample that you got if this was true. And if the p-value is tiny, that's the evidence you want, right? Right. You want it to be nothing point nothing nothing one, because you'd want to say, look, the chances that it's true is so small that that can't be true, and therefore this must be. And the test for that is your p-value less than alpha? Can anybody remember what we call alpha? It has a name as well. It's 2 words. What was alpha called? Last chance.
The probability value p. Sorry, I no.
You lost it. It's
Significance level.
That's the word I was looking for. Right? It is the probability that you got it wrong, which is what I think Forrest was getting towards. But the name I was wanting is like its official title. It's called the significance level. And then you do a conclusion. And the conclusion is going to be one of these 2 things. Not enough evidence to reject the null, or there is enough evidence to prove the alternate is true, right? It's going to be one of those 2. If the p-value is less than alpha, or if the p-value, right, is more than alpha, let's see. If it is more than alpha, then there's not enough evidence. And if it is less than alpha, if that's what happened, there is enough evidence. That's pretty much how this process from start to finish is going to work. So far, so good? Let's put this to the test. They don't get you to do, every question isn't do the whole thing. A lot of questions are just do the bit at the beginning and that's all. So if I can move this little guy over here. Okay, stop sharing and reshare. Here we go. So in each of the following, determine whether the conditions for conducting a Z-test. I wish they hadn't phrased it that way. I wish they'd said the conditions for conducting a hypothesis test. I think that would have made more sense to me, but that's their phrasing it. It's the same thing. And let's find out. So the question is, can you do a hypothesis test in each of these stories? So in the first story, a company employs 600 stockbrokers. They're all, that's key here, surveyed to find out whether the majority believe that the market will go up next year, right? So they're going, you know, it's an investment house, right? And they've got none but stockbrokers working for them. And they ask them, okay, all of you, is it going to go up? Oh, 82% say it's going to go up, right? Or whatever the answer is. And they want to know, is the majority. So the null hypothesis is 0.5. And if it's a majority, don't you want to prove that it's bigger than 0.5? But here's the question. They asked everybody, should you be doing a hypothesis test when you ask everybody? No. Now, it's not a random sample from a large population, or no. I would have said this is a census, but well. Well, you're right, it's not a random sample from a larger population. It's actually everybody. Ooh, I don't like that phrasing. Let's double check. Yeah, I didn't like the way they phrased that. I would have said it's a census. But then again, I wouldn't have said a Z test, wouldn't I have said the hypothesis test. Okay, a market research. Oops. Okay. A market research firm wants to know whether more than 30% of the people, and it asks 50 people as they're leaving, and they're saying no. It's not a random sample. Now, why is it not a random sample? Oh, they get people leaving at noon. Would you agree that's not very random? Couldn't there be a lot of people inside working? And you're not going to ever ask them. Okay, so that was not random. I got that. Let's put these answers out the way. They're distracting me now. I think I've done a silly thing here. Question 1 and 2 are essentially the same, so I won't go into that. Now, starting at question 3, they're asking you to find a Z-score. And here is the null and the alternate. And here is the p-hat. And here is the n. So everything that you need is there. And I'm just writing them down again. So I know the sample is 30. I know p-hat is 0.55. I'm being told H0 and HA. And they want me to get the Z-score, right? Okay, so let me show you how I would tackle that using SALT. Most of what I need was given to me, but there was some things I need to check. So since p-hat is equal to 0.55, when we do it in SALT, don't we always give the answer as 412 out of 900, right? It has to be an out of. So first thing I'm going to do is find what 0.55 of 30 people is, and it better be a nice number. Look at it. Oh, it's because they randomize the thing and they don't pay attention to real life. You cannot get 16.5 people of anything, right? But unfortunately, that's what I'm going to be using, 16.5 out of 30. Okay, and I'm ready. Oh, P is 0.5 and P is not equal to 0.5. And I'm going to get the Z-score, and even if they didn't ask it, I'm going to get the p-value as well, because that's really the number I want. And now I'm going to return back to here, and I'm just going to find use SALT. Inferential statistics, one sample proportion, and the number of successes is 16.5 out of 30, and please don't get annoyed, software. Okay, I'm going to go for it and say, nah, darn it. Okay, I'm going to have to improvise 16 then. Going to generate the results. No, it's not going to work. Okay, plan B. I thought that it would tell me the Z-score, and I was wrong. So I have a plan B. we did actually do this by hand, and I wish we didn't need to because it's laborious, but we can do it. N equals 30, p hat is 0.55. All I need to do is find the standard error of p hat. And the standard error is p naught, 1 minus p naught, all over n. In this case, that number there is our null value. So p naught is 0.5. So I'm going to do the square root of 0.5, 1 take away 0.5, all over 30. And on my calculator, the square root of 0.5 times another 0.5 divided by 30 is 0.0913 roughly.
Okay, how you got the P note to 0.5?
There,
How did you calculate that?
it was 0.5. In the question, they told me that was 0.5 and that number there is p naught. So I didn't need to calculate it was in the question. So we got a standard error. And yesterday, we took you through it and I was saying, look, we don't really want to do this by hand. That's what SALT's for, but evidently I don't know what I'm talking about. The formula is that one. Can you remember it for the z-score? P hat, p naught over the standard error. P hat, again, that was in the question. P naught, standard error, on our calculator then, brackets 0.55, take away 0.50, and divided by 0.0913. And the answer I get is 0.548 if you want it to 3 decimal places. Okay, so right, that was question 3. Come on, give me the answer. There you go. And I will zoom down there and do question 3. And to 2 decimal places, it's 0.55, because evidently that's what they wanted. And let's show you it then. So we had to do all of that by hand, but can you see the answer? Right, so it does work. Now you do get the p-value from SALT, but evidently it doesn't want to tell you the z-score. Now I'm going to have another look just in case. Okay, are you looking at SALT here? You're looking at the guy? Right, it doesn't tell you Z, does it, anywhere?
Mr. Robertson uses the confidence interval instead of the hypothesis test.
Oh. Well, the Z statistic does work, but it doesn't work if you're 16.5 because the thing won't like it, will it? Yeah. Okay. As long as the number of people who said yes is a real number like 14, you can do it this way. If it's 16.5, you're going to have to do it the hard way, which is a real pain in the posterior. Okay. So let's try the second one then. In the second one, the sample size is 60. P naught is 0.25. You're being asked to find, is it less than 0.25? and p hat is 0.15. Okay, so all I need to do is find out what 0.15 of 60 is. And so that's 9. Okay, here we go. One sample proportion. 15% was my sample, which ends up being 9 out of 60. If I then move on to the hypothesis test, they want this to be 2.5, and you're trying to prove that it's less than that. And so generate results. There's the z-score that they're looking for. Are we okay with that? As long as it's a whole number, you can plug it all into here. And if you want the p-value, which is more realistic, aren't you going to get the same answer from there? Okay.
I am so sorry. Can you hear me?
I can hear you. What is up? What's up?
I disconnected. So the last thing that I heard was how to do the work for A on number 3. What are we doing for on solved right now? Which question?
We are right now just finished doing question 3, and we're about to do question 4. Okay. Right. So I'm going to take question 4 and write down all the information, and then I'll transfer it into solve. So in question 4A, we were told that the sample size is 100. And we're told that p hat is 0.29, which, by the way, is 29 out of 100. That transfers well. We have a null hypothesis that says p equals 0.2, and we have an alternate, the one that we want to prove, and that is that it's actually bigger than 0.2. And we are only going to get the Z statistic. Right. So that's what question 4A looks like. So I'm now going to go in and do that question, hopefully, using salt. Right. Are you looking at the salt screen? Okay, so one sample doesn't change. In this story, it's now 29 people out of 100. The null hypothesis was 0.20, and we're trying to prove that it's greater than that. And then I generate my results, and there is my z-score, 2.25. Would you agree? It's pretty easy once you put the numbers in, except for 16.5, which is weird. Another one? Okay. The one underneath that then is question, oh, by the way, 2.25, right? It works. In question B then, let me move over and kind of do the putting it all together thing. 200 people in that sample. P hat is 0.48. And we need to know what that looks like in terms of the sample size in this number. So essentially what I'm going to do is I'm going to find out what 0.48 times a sample of 200 would get me. And the answer is it would get me 96 out of 200 people. And that number I need, or those numbers I need. The null hypothesis in this story is that the percentage is 0.8. And we are trying to prove that our guy is less than that. So everything is here will get me the z-score. So back into salt. I've lost it. Where are you, Salt? Here you go. In this question, we have 96 out of 200 people said yes to whatever the survey was about. This P0 value was 0.8. That's null value. And we want to prove that it's less than that. So sample out of the null value, want to prove it's less than it, generate results, and wow, look at that as a guy. Negative 11.313708. If you get a z-score that's like that, isn't that extremely unlikely to be luck? So that's the evidence you're looking for. And if I move this thing out of the way, can you see the negative 11.31 to 2 decimal places so we know it's worked? Are you looking at the answer? Right. Any questions about that? Is it getting a little bit cleaner? Now, I'm going to have to get the answers out of the way because they are going to be a pain for the next question. Oh, and by the way, do you notice that they don't have a salt button in a lot of these questions? I just had to find a random salt button and get in that way. So we are on this one. A hypothesis test is done to determine if the proportion of a certain ethnic group have a blood type A is greater than 40%. In a sample of 1,000 individuals from this ethnic group, 440 had type A blood, and the results were that Z is 2.58 and that the p-value is 0.0049. Provide a numerical value for each of the following. So I'm not even needing salt here, don't I just need to know where the information is and write it down again? So you want to know the p-value. There it is. Now, p-hat does require a little bit, but just a little bit of calculation. Wasn't p-hat the 440 out of your 1,000 sample? And 440 out of 1,000 will get you a 0.44. Now, who is p0, right? We call it the null value. What number is the null value here? It's in the story. Where is it hiding?
Is it 0.4?
Yeah. 0.4. And the reason? If you want to prove something is greater than 40%, isn't the base number 40 and you want to prove it's bigger? And that's the end of that question. Now, in this bunch of questions, you even have a salt button. And you have kind of the numbers you need, but you have to do a little bit of calculation. I'll give you what I'm after here. Do you see how the sample p-hat was 0.34? Don't I need to know that guy? And I
I'm
need
sorry
to know
for the
how
last
many.
question. What was A?
Yes.
How did you get
A was
for-
0.4. It came from the 40%, if you prefer 0.40. If you're trying to prove something is bigger than or less than a percentage, that number you're trying to find it bigger or less than is your null value, your p0. So if you have a story and say, I want to prove that the majority of people are in favor of this, 0.5 would be your p0. If I want to prove that more than 80% like Pepsi, P naught will be 0.8, 0.80, 80%. Okay, this guy here needs a calculation done to it, but we are going to get the P value. So I better write them down because they disappear the minute I click on salt. I know P hat is 0.34. I know that N is equal to 100, and we are just going to be looking for finding the P value. Now that I've done that, I'm going to show you a little calculation I want before I can go into salt. Pretty much everything I know is here. That's my P naught, right? That's my sample, that guy. But these two guys have to be turned into, in this case, 34 out of 100, right? You have to have it that way. Tell me it's 0.34 doesn't work with salt. Salt doesn't want to know it's 0.34. Salt wants to know something out of. So since this is 100, 0.34 of 100 gets you that. And we are ready to rock and roll. Let's see what we get out of salt here. Normal distribution. And that's not what I want. There we go. Number of successes, 34. Out of how many? Out of 100 people. That's the 0.34 from my sample. Hypothesis test. That guy there was 25. And I forgot what we're trying to prove. We're trying to prove it's greater than. So, greater than. So 34 out of 100. The null value is 0.25, and we're trying to prove it's bigger. Right, so that's all of that's done. Generate results. There's your p-value.
For my number 3B, it's not coming out right.
Okay,
What if the P hat is less than the HOP? Because
if it's less than, then you go here and you make it less than.
No, I mean,
Or you
doing
mean
my
your
head-
numbers not the
Huh?
same? Are you telling me that the answer you got is not the same value as the one that?
Well, the answer I'm getting
It's
is
not
wrong, but I'm doing it correct, I think.
Okay, let's try it then. 1, 2, 3, 4. Right. Okay, so what were your numbers? Is it question A you're talking about or B?
Number 3B,
3B. Okay, so you have 200 and that guy. Did you use 118 out of 200?
no, mine's different than yours.
Okay, what was your p hat?
My P hat is 0.2,
Okay, and what was your sample size?
60.
We're talking question 6, right?
No, I'm talking number 3B.
Well, that might not be the same question then. Yeah, because in 3B, you're wanting a z-score. You're not wanting a p-value.
Yeah, I know, that's what I'm figuring out, but it's not coming out right.
Okay, let's work backwards on that one, then we'll go return to the one we've just did. So in question 3B, you were told the sample size was 60. You were told that p hat was 0.2. And then you had in your question an H naught and an HA. What does your H naught say it was equal to?
0.25.
And was this a bigger than or a less than for you?
Oh, it's
What-
P is less than 0.25.
Okay. Now this question you can't use salt because they want a z-score and it didn't. Well, actually you could use salt. What am I taking it? As long as this works out right. 0.2 of 60 ends up being 12 people out of 60. Did you get that?
I didn't even do that because I tried doing the for the like the 3A.
No,
agree.
yeah, the 3A was a different method because it had 16.5 people. But as long as it's a whole number, we can do it this way. But I can do it this way. We'll do it with salt, and then we'll do it the other way, and we'll show you get the same answer, right? Just to show you both methods work.
So the
So-
answer is 12?
No, that's just the number I'm going to use to get the answer, right? We've other things to do. So I know it's 12 out of 60. I know this is the null. That's the null value. And I want to prove it's less than. So let's see what salt does. So I'll nip over to salt and we'll see what calculations it comes up with. Here we go. And here I'm going to put 12 out of 60. And hypothesis test, I want this to be 0.25. And I want to prove that it's less than, and I want to generate results. And the Z statistic I get out of that is negative 0.894427, right? That's what they asked before, right? The Z score, the Z statistic. Okay. Now, can you see this? You got to tell me if you don't see things, or I'll just rant on forever thinking you're seeing it. Right, I will go back in, and can you see it now? So can you see salt? Where are the buttons? Okay, so I put in 12 out of 60. I put the 0.25, I did the less than, and now I hit generate results, and this guy here is the Z score, right? So I'm going to copy that guy, and well, I can't put him in because my numbers
So
are
it's easier
different.
just to find a random question that has salt than just use salt.
You can use salt in almost every question, even the ones that don't have a salt button. And I think if you use salt, you get more accurate answers and it's quicker. There are
For
a
sure.
couple that I couldn't avoid, but that one is working. Now, if you want to do that same calculation by hand, and I kind of promised that we would do that, just to show you, you can get the same Z score with the same information, right? So what we're going to do is we're going to calculate the standard error. And the standard error is the square root of P naught 1 minus P naught over N.
0.06.
Now, when you're doing it, make sure you use this number. This guy here is P naught, not any other number, not that number, this one. So it's going to be 0.25, 0.75 all over 60. So I'll go here and figure out what that is. Square root of 0.25 times 0.75 all divided by 60, and I get 0.0559. Now to get the Z score, it's P hat, take away the value of P naught, divided by the standard error. That's how you would do it by hand. P hat is 0.2. P naught is 0.25. Divided by the standard error 0.0559. Now I want that guy to be pretty much this guy bar rounding off. So let's see what we have. A bracket 0.2, take away 0.25, close the brackets, divided by 0.0559. And would you agree that is pretty much the same guy?
Oh, because I rounded off too early and I just did 0.06 instead of 0.0559.
That is
Because
so easy. That is so easy to do, isn't it? That the advantage is that salt doesn't do that. So you're, you know, as long as you round the final answer off, you are good. Now, the majority of questions that we are going to be doing, it's not the Z score that we're going to be finding. It's that more important number, the p-value that we're going to be finding. So I think I was at question 6, was I? Yes. Did we finish off 6A? I think, yes, we did. Okay, I'm good. I'll do 6B then, just to get us back into the swing of things. Right, so I'm just writing down my version of what 6B has. You have a sample size of 200 and you have a p-hat of 0.59. Now I'm combining them by multiplying these together and hopefully getting a whole number. So that's 200 times 0.59. And that gets me 118 people out of 200. I need that for salt. That's not any good. Salt needs this. We have an H naught in the story where P is 0.75. And the alternate is that I'm trying to prove that it's less than 0.75. When we're finished, it's the p-value that we'll have. So now that I've got all the guys, all the data that I need, with a bit of luck, you should get it to work. Use salt. Right, are you looking at salt? Right, hit inferential. Make sure that it's in one sample. It was 118 people out of 200. This was 0.75, and we were trying to prove that it was less than that. Okay, so that's basically all you need. Something out of 200, what the null value is, and do you want it bigger? Do you want to prove it's less, or do you want to prove it's not equal to? So I'll generate results, and we got a value that is essentially 0, right? For all practical purposes, it's 0. So I'm going to put in 0 there, and I'm going to check, do I need to put 0.00001, or will it take 0, right? So let's find out which it takes. Put in the key. Zoom it up and down a few times so it knows what I want you to do. Do you know it didn't do either of the two choices? 0.0000 to 4 decimal places. 0.00001 is 0.40. Is that not being pernickety? Isn't it? That's just being awkward for the sake of awkwardness. Essentially, you've got all the evidence in the world that what you thought, i.e. it's less than 0.75, is in fact quite true. And we've reached the end of our time because this one will take more than 2 minutes. So last name, and bye-bye for now. When you're doing these homework questions, just because there isn't a salt button there, doesn't mean you can't use salt, okay? Because if you have to do them all by hand, it'll take you 4 times longer than it needs to.